Imagine walking into a factory floor worth $50 million. Robotic arms welding steel, conveyor belts moving thousands of parts per hour, and right in the middle of all that precision engineering, a beige desktop tower running Windows 7, not as a backup. As the brain of the entire operation, you think that's a joke. It's not. And today, we're going to find out exactly why that machine stays, why engineers fight to keep it, and what that tells every single one of us about how we think about old technology. If you work in IT, manufacturing, or you just care about not throwing away hardware that still works, this one's going to hit different. Welcome to Tech Renew Deep Dive. I'm not here to sell you on new gear. I'm here to help you understand what you already have and squeeze every last dollar of value out of it before you even think about replacing it. Today's topic sits right at the intersection of industrial engineering, operating system architecture, and the very concept of programmed obsolescence. This is not a rant. This is a technical argument, backed by real-world data, for why outdated is a word that needs a lot more context before anyone uses it. Let's start with the money, because there's always money behind every technical decision. A mid-size automotive components factory runs on what's called a CNC machine. Computer Numerical Control. These machines are programmed to cut metal within tolerances of a few thousandths of an inch. The software that talks to that machine? It was written in 2003. It runs on Windows XP or Windows 7. It has never crashed during a production run. It produces 0 defects when calibrated correctly, and the license for that software cost $400,000. Now ask yourself, why would any rational engineer replace that? The answer most people give is security. And that's a real concern, but it's also the answer that hardware vendors and Microsoft want you to give. Because fear is the best sales tool ever invented. Here's what the people selling you Windows 11 upgrades don't tell you. Most of these industrial machines are air-gapped. That means they are physically disconnected from the internet. No Ethernet, no Wi-Fi, no attack surface. A 0-day exploit on an air-gapped Windows 7 machine is about as dangerous as a car thief who lives in another country. The threat model simply doesn't apply. So security, in this context, is mostly theater. Let's talk about what's actually happening under the hood. Windows 7 was built on the NT 6.1 kernel. That kernel was designed with deterministic behavior as a priority. In industrial computing, determinism means the operating system responds to hardware interrupts within a predictable, repeatable time window. Every single time. Modern operating systems, Windows 10, Windows 11, are built for a very different use case. They're built for consumer devices. They prioritize background telemetry, automatic updates, dynamic resource allocation, and cloud integration. Every one of those features introduces what engineers call non-deterministic latency. The system might pause for half a second to phone home to Microsoft. In your laptop, you don't notice. In a CNC machine cutting aluminum at 3000 RPM, that pause breaks the part and potentially destroys the spindle. This is not a bug. This is a fundamental architectural difference between an operating system designed for human interaction and one designed for machine control. Let's go deeper. Industrial controllers use something called a real-time operating system layer, or RTOS, that sits between the hardware and the software. On older systems, Windows 7 was certified by the machine manufacturer to coexist with that RTOS layer within specific interrupt latency thresholds, usually under 1 millisecond. That certification process took years. It cost hundreds of thousands of dollars. And it was done once. Migrating to a new operating system means recertifying the entire stack. You're not just reinstalling Windows. You're retesting every driver, every hardware handshake, every timing dependency across the entire machine. For a production environment, that means downtime. And downtime in a factory that runs 24 hours a day, 7 days a week, costs more per hour than most of us make in a month. Some factories pay between $10,000 and $100,000 per hour of unplanned downtime. A migration project that takes 2 weeks of testing and a 48-hour cutover window. The math doesn't work. It simply doesn't work. Now here's where it gets philosophically interesting, and this is what I want you to take away from this video. The entire premise of "this software is outdated" assumes that newer is better. But better for whom? Better for what use case? Windows 11 is better for browsing, for gaming, for running modern applications. It is categorically worse, not just less good, but actively worse, for deterministic real-time industrial control. The use case defines what better means. And when we forget that, we start making expensive, catastrophic upgrade decisions based on marketing language instead of engineering logic. This is the core principle behind everything we do on this channel. Technology is not outdated when the calendar says it is. Technology is outdated when it can no longer perform its intended function efficiently and safely. That's it. That's the whole definition. Let's talk about DRAM and processor architecture for a moment, because this also matters. Older industrial PCs often run on processors from the Core 2 or early Core I series. These processors have something modern chips have largely moved away from: consistent, predictable, single-thread performance with no efficiency cores, no performance cores, no scheduler confusion. The operating system knows exactly what it's dealing with. The RTOS layer knows exactly what it's dealing with. Everything is boring and predictable. In industrial control, boring and predictable is the highest possible compliment. Modern hybrid architectures, like Intel's Alder Lake or Raptor Lake, introduce asymmetric core layouts where the scheduler dynamically moves tasks between performance cores and efficiency cores. For most workloads, that's brilliant. For real-time control loops that must execute on the same logical core, at the same priority level, within the same time window, every single cycle, it's a nightmare. Engineers have documented cases where migrating to newer hardware caused intermittent timing failures that took months to diagnose. Months. And here's the part nobody talks about: the software supply chain. The proprietary software that runs these machines, the HMI, the SCADA systems, the DCS platforms, these are written and maintained by companies that may have 20 or 30 engineers total. They don't have the resources to continuously port their software to every new operating system Microsoft releases. Their customers don't want them to spend money on that. Their customers want the machine to run. So the software stays on the platform it was certified on. Period. Now, what does this mean for you? Whether you're an IT manager, a hobbyist, or just someone trying to make smart decisions about technology. Here are the practical takeaways, and I want you to write these down or screenshot this. Number 1. Always define your threat model before making any upgrade decision. If the machine is air-gapped and performs a single deterministic function, the security argument for upgrading is weak. Do the actual risk math. Don't let fear-based marketing make the decision for you. Number 2. Differentiate between support end-of-life and functional end-of-life. Microsoft ended mainstream support for Windows 7 in January 2020, but functional end-of-life, the point where it can no longer do its job, is a completely different date. For many industrial applications, that date has not arrived, may not arrive for another decade. Number 3. Before recommending a migration, document the full cost. That means downtime cost, recertification cost, retraining cost, and regression testing cost. In most industrial cases, total migration cost exceeds the cost of maintaining the legacy system by a factor of 3 to 5. Make the decision maker sign off on the real number. Number 4. If you are running legacy systems and you do need to improve security without migrating, look into network segmentation and application whitelisting. Tools like Carbon Black and CyberArk can create a locked-down execution environment on Windows 7 without requiring any OS migration. You get meaningful security improvements at a fraction of the cost. Number 5. Document everything. Every driver version, every hardware revision, every software build number. The engineers who certified these systems are retiring. The institutional knowledge is leaving the building. If you don't capture it, you will eventually be forced into a costly migration. Not because the technology failed, but because nobody remembers how it works. Here is the bigger picture. The industrial world's resistance to upgrading Windows 7 is not stubbornness. It's not ignorance. It's a rational, economically, and technically defensible position that emerges when you apply rigorous engineering logic instead of consumer market assumptions. These factories are, in a very real sense, practitioners of everything this channel is about. They are extending the life of their technology because the technology still works. Because replacing it would cost more than maintaining it. Because the new thing is not actually better for their specific use case. That is the philosophy of tech life extension. Not hoarding, not nostalgia. Rational, evidence-based refusal to replace things that are not broken. If that philosophy resonates with you, if you're tired of being told that last year's hardware is garbage and this year's hardware is the only option, subscribe to this channel. Because every week we go this deep into a different corner of the technology world. We talk about thermal throttling in aging laptops and how to fix it. We talk about RAM optimization on systems with older memory controllers. We talk about the real economics of repair versus replace. And we do it with the same level of technical rigor you saw today. Hit the subscribe button, turn on notifications, and drop a comment below. I want to know, have you ever been pressured to upgrade a system that was working perfectly fine? Tell me what happened. The comment section on this channel is not a place for takes. It's a place for actual engineering stories. Let's hear yours. This has been Tech Renew Deep Dive. I'll see you in the next one.